Okay. So we are plugging in -6. Which piece do we plug in -6 to? The top one, because it says we're using x values that are less than -3. -6 is less than -3. So we've got -6 plus 2 plus 4. That was me saying the answer. -6 plus 4 squared is the same as -2 squared, which is 4. Okay. Which one do we actually get to plug -3 into? Because they both say -3. The bottom one, why? Because it's got the equal sign. So we're going to say negative of -3 minus 3. So minus minus makes a plus. We got 3 minus 3 is 0. All right, which one do we plug 0 into? The bottom one, okay. So we got -0 minus 3. And -0 minus 3 is -3, okay. And then which one do we plug 10 into? The bottom one. So -10 minus 3 is -13. Okay. For the domain, if you guys notice, we've been doing domain and range, and then we got to piecewise functions, and that got a lot more difficult. Did you guys notice that? It got a lot more difficult. So when we do domain and range, I am not going to, on a testing situation, give you a really difficult one. I'm going to try to give you ones that are a little bit more straightforward because this is Math 3, this is not calculus. This is not pre-calc. But I'm going to show you guys some more difficult ones because I want you guys to be able to see like, oh yeah, there's a reason we did simple ones so we could understand it because things do get really complicated really fast. Does that make sense? Okay. So for domain, we're looking from left to right. I can see that it goes left forever. I can see that it goes right forever. But before I decide to say negative infinity to positive infinity, I have to make sure it doesn't skip anything in the middle. Okay, so when you look at the x values, is there an x value that gets skipped?
No.
No, so I feel a little bit weird about -3. Something could have happened there. But the other one has a -3. So I'm not worried about it after all. So -3 really gets used. So for the domain, I'm going to say negative infinity to positive infinity. You guys noticed that on the warm-up it got skipped. For one of them, there was one of the ones with the square root in it. There was a little gap in there. So it's possible to skip a few of them. Yeah. Okay. For the range, we go from down to up. I see a down arrow. I see an up arrow. Are there any y values in the middle that get skipped? There's some y values that are redundant, right? Like a y value of 0 actually gets hit twice. But there's nothing that gets skipped. So this range is a lot easier than the range from last night. All right, negative infinity, infinity, negative infinity, infinity. Okay, how do I do increasing and decreasing? Yeah, so I'm going to go ahead and just do the little stick figure, right? So what's happening with the stick figure? Yeah, what's his name? Jeremy, the stick figure. That's just a lot of syllables. Ted the stick, like Ted Bundy, or Ted the bear? No, Ted for me just means Ted Bundy. Fred. How do we feel about Fred? Fred, okay. So this is Fred. What is Fred doing? He is skateboarding down a very steep, what are they called, pipes? Yeah, okay. Did I sound cool? He's gonna shred the nard hardcore, bro. So he is decreasing up until right here, and then what happens? He increases, no, and then there's a hole in the space-time continuum, and he falls through it, and he dies, and then there's another stick figure.
What's his name?
Fred 1 and Fred 2. No, this is Kathy. Yeah. Okay. And what is Kathy doing? So she's going down. Okay. So let's put some x values in here. What is the x value of a left arrow? Negative infinity. Okay. What is the x value right here? Negative 4. What is the x value of the hole in the space-time continuum where Fred died? Negative 3. Where did Kathy get started? We can go for Karen. Kathy Karen? All right, so Kathy Karen started at negative 3. And then where did Kathy Karen end? Infinity. She doesn't. She goes forever. All right. So for increasing interval, we only have a very short period of time, right? A very small answer. And what's our answer for that? Negative 4, negative 3. That's this little piece right here. So increasing interval is negative 4, negative 3. Always parentheses. We're not trying to kill any raccoons. No, she's just going to go, well, she's going to go until she dies, and then she's just going to fall off her skateboard. Because she's doing it forever, so it's like, I thought she was skateboarding. No, Brad was skateboarding. She was biking. Okay. All right, decreasing interval. The first decreasing interval is negative infinity to negative 4. Okay. Wait, does it include ever on increasing, decreasing? No. Okay. And then Kathy Karen is negative 3 to infinity. And then what do I put in between? A U. Okay. All right. So maxes and mins, we're looking for mountaintops. We're looking for valleys. I don't see a mountaintop, so I'm going to say none. I do see a valley. What's the valley? Negative 4, 0. Okay. All right. X-intercept, Y-intercept. I see both. What's the X-intercept? And then the Y-intercept is 0, negative 3. Good. Okay. So these are intervals that are written with parentheses. This is an X and a Y coordinate written with parentheses. The parentheses do not mean the same thing. Oh, yeah. Thank you. Yeah. Thank you. Yeah, 2 X-intercepts. I got so caught up in the first one, I forgot there was 2. All right. Kathy Karen. All right. Is this graph continuous? No. Okay. End behavior. As x goes to negative infinity, as x goes to positive infinity, a chocolate Laffy Taffy is definitely a Tootsie Roll. Maybe we should just call her Tootsie. Fred and Tootsie. All right. So as we look at the left arrow, what is it doing? What is the left arrow doing? It's going up. Left arrow goes up. The right arrow goes down. Okay. Left arrow goes up, right arrow goes down. Miss Rice, how do you graph this? I was waiting for you to ask that. Let me show you. Yes. Yes, let me show you. Marvelous. You get an A+. Okay. I'm on a blank graphing screen. Okay? I am going to type parentheses x plus 4 squared. And then I'm going to hit the divide button. I'm not dividing, I'm computer programming. Cool, huh? Okay, now we have to say x is less than negative 3. Did you see I put a parenthesis there?
Yeah.
Okay, so now I'm going to type an x. And then I'm going to hit second math. Second math less than negative 3. Second math, x is less than negative 3. Okay? Now, if you have an old color calculator, still try it, because the benefit of doing this the old way in your color calculator is that each of the little pieces will be a different color, which is kind of nice. There's also a way in your color calculator to graph it all at once, but then it's all one color and you don't get to see which piece is which. So it's beneficial to know it both ways, even if you have the super calculators. Okay, and then we've got negative x minus 3. Got our division symbol. Not actually dividing, though. I'm like, programming it in my computer. So this is me saying, use this graph, but do it for a specific domain. So that's going to cut off part of the domain. All right, so now I've got x, and then I have to do is greater than or equal to, so I hit second math, is greater than or equal to negative 3. Make sure your window is normal, negative 10 to 10, or if you want it to match this graph, we could change it to negative 8 and 8. Then it will look exactly the same as the graph that we just were looking at. So if it says error, typically it says quit or it says go to. I would hit go to because it might be that it might show you that you just did the wrong negative somewhere. You did a minus instead of a negative in the front. And I'll come over and I'll look at it. Okay.
Whoa.
And that looks like our graph. Now here's the other cool part. If you hit second graph and you look at the table, the errors will show you where you cannot plug the number in. So if I want to plug in negative 6, I better get 4 as an answer, not error as an answer. So that means I'm using the first piece. I am not using the second piece. You probably did not actually get all errors. You get errors on one column, but not in the other column. And then say it again? It means your domain is probably not right, and I can come over and look at that for you. All right. Number 3. All right. Let's get this one plugged into our calculator. We can use it to help us do the problem. So I've got x plus 3 squared. Division. I'm going to start plugging in the domain. Now, when you get to the second one, you're going to have to wait because this one is not as easy to plug in as you would think. Okay, we all got the first one plugged in? Okay. So to type this one, anytime we've got like a sandwich going on here, our calculator, unless you have the brand new color ones, which some of you will once I update your calculators, but unless you have that, your calculator does not like this notation. So the way that you type this in is you say x is greater than negative 3. Do you guys see how that came to be? So the bigger part is towards the x, so that really means x is greater than. X is greater than negative 3 and x is less than or equal to 2. That's what we're about to have to type. And we have to plug in all of that, including the word and. We're going to get that in there in a second. So we're going to do absolute value of x minus 4. How do I get absolute value? Math over. Okay. So absolute value of x minus 4.
Do that have to be parentheses?
It's not parentheses because it's the absolute value sign. If you put the whole thing in parentheses, it shouldn't be an issue. Yeah. Okay, divide by, and then parentheses, and now we have to type this whole thing. So now I'm going to say x second math is greater than negative 3. Anyone remember from the video how I get the word and? And then go over to logic. That's how you get the words. So second math and. You do not put parentheses yet. We're going to do the whole thing and then we're going to end the parentheses. So x is greater than negative 3 and x is less than or equal to 2. All right, and then we got the last one, square root x minus 4. Now, this is a helpful tool. This is not meant to be a crutch. It is possible for me to give you a piecewise function on a portion of a test that is not calculator active. Why, Miss Rice? Because you're on the honors track, you're potentially going to go to pre-calc, you're potentially going to go to calc, and you're going to need to be able to do things by hand. Okay? Okay, we got it typed. How would I do it without? The and? So on the new calculators, you can type it in and make it look exactly like that, and it will handle it just fine. You still type it in parentheses, you don't put the word and, but is your calculator the really updated one? Yeah, okay. You'll notice because it will either graph it correctly or it won't. All right, so this is what we have. You guys got it? All right, now let's go ahead and plug in negative 30. So which one am I plugging in negative 30 to? The bottom one? It's negative 30 though. So it's the top one. Okay, so we got negative 30 plus 3 squared. What is 27 squared? 27 squared is 729. Big number. Oh, you said x is less than negative 3 instead of greater than? Yeah. Okay. You use the wrong type of negative. You use the minus button instead of negative. Okay. So we can plug in negative 30, or I'm going to show you another thing on your calculator. Hit second window. If I want to plug in negative 30 and I don't want to go to the table and just scroll until I get to negative 30, I can hit table start and hit negative 30. I did second window. See how it says table set? Negative 30. Now if I hit second graph, aha, negative 30. Aha, 729. I got it. That way you don't just have to sit here for 20 minutes and scroll. Okay, let's get it back to a normal spot. So I'm going to hit second window, and I'm going to go back to 0. Okay, so now I'm back to kind of normal numbers. What if I want to plug in negative 3? What do I get? Okay. What if I want to plug in positive 2? Error, so I don't use that one. I use negative 2. Okay. What if I want to plug in 0? I don't use error. I use negative 4. What if I want to plug in 3? It says error, error. So I go over. All of them are error. What does that mean? Yeah, we're going to say undefined. No. Okay, now if we were to do these by hand, if we were to do it by hand, -3 gets plugged into which piece? The first one. -3 plus 3 is 0. 0 squared is 0. That's how we got the answer. Okay, where do I plug in 0? The middle one. What is the absolute value of 0? 0. 0 take away 4 is -4. Which one do I plug 2 into? The bottom one? The middle one? The middle one, because it can equal 2. Absolute value of 2 minus 4, -2. Which one do I plug 3 into? The very bottom one. Square root of 3 minus 4 is not 1. Square root of 3 minus 4 is square root of -1. That's a fake answer, which is why we say it's undefined. Yeah. Okay. All right. Domain. We got a left arrow. We got a right arrow. Domain. We got a left arrow. We got a right arrow. There's stuff in between that's getting skipped. Do you guys see that? And we're noticing it's the square roots. Those are the ones where we start to skip stuff. Because square roots don't go left and right forever, right? If we look at the whiteboard, all the graphs that we've looked at so far go left and right forever, except for the square root. You guys notice that? Yes. And so oftentimes when we see that square root, we're going to see that there's a gap. Okay, so we've got left arrow. It looks like -3 might be a problem, but is it a problem? No. Okay, so -3 is good. What is the actual problem then? +3. It's like right in here. Okay, so the domain is -infinity to 2. Is the 2 included or not included? Included because it's filled in. That is not an open circle. So we're going to say included. Okay, these are a problem, and then where does the graph pick up again? 4. Is the 4 included or not included? They didn't draw a circle, but if they didn't draw one, that means that it can't be open. It has to be closed, because if it was open, they would have had to draw it. Okay? So there's no circle here. That means that if there was one, it would have to be closed. So you count it. So 4, and then it goes to infinity. Because you can't touch infinity. I can touch that point with my finger. It's really there. I cannot touch infinity. You put a U in between because you got 2 answers. Okay. Range, we're going from down to up. So, does it go down forever? No. How far down does it go? -4. Does it include -4? Yes. Okay. And then we start to go up, and it looks like 2 might be, it looks like -2 might be a problem, but is -2 a problem? No. So it's a problem over here, but it's not a problem over here. Okay, so we're going to keep going up. And then it looks like -1 is a problem. Is -1 a problem? It is a problem. Okay, so we're going to say -1. And what do we notice about -1? It is not included, so we put a parenthesis. Okay, and then we've got some decimals in here that are still a problem. They're not included. And then what number do we have next? 0. Okay, is 0 included? Yes. Okay. And then as we go, we have up arrows to infinity. And then what do I do with the infinity? And then what do I do in between? Okay. So the trick to doing these with domain is to go from left to right, and for range is to go from down to up, and just keep track of what is there and what's missing. Does that make sense? If it's there, you include it. If it's missing, you don't. That's basically what domain and range are asking. Domain is asking what x values are there, and range is asking what y values are there. Okay. So here is Fred. Okay, so Fred is going downhill, hits a black hole, dies. I'm not sure what happens to Fred. Tootsie Tiffany climbs out of a hole. No, it's Tootsie Tiffany. Tootsie Tiffany climbs out of a hole, and then what is Tootsie Tiffany doing? Strolling until she hits this, and then she is going up, and then she also falls into a black hole. Okay. And then Humphrey crawls out of the ground. He was buried alive. He crawls out of the ground. And then he accidentally crawled into a cannon and gets shot up into the air. Okay.
They just stick him in the cannon and then he finally.
He accidentally crawled into a cannon. I feel like that would happen in a cartoon. They'd be like buried alive. They're crawling out, and then they're like, "Where am I? I'm in a cannon," and then they shoot off. Yeah. Okay, so we have negative infinity. What do we have right here? Where did Fred die? The black hole. What number? -3. Tiffany Tootsie, or was it Tootsie Tiffany? Tiffany Tootsie? Tiffany Tootsie? TT. All right, so TT was right here, and that's at -3. And then where did she switch directions? Not at -4. At 0, because we're using the x coordinate. That's right. And then she got into the black hole at 2. Okay. And then we have some space where nothing was happening. And then when did Humphrey crawl into the cannon? And then he was shot into the cannon, and how long was he flying? Forever. Humphrey? All right. So increasing interval, we have 2 answers. Our first answer is 0 to 2. Why did I put parentheses and not even ask you guys?
Because it doesn't matter.
Because it doesn't matter, it's always parentheses. Okay. What do I put for over here? We have 2 answers for increasing because I wrote increasing twice. One's here, one's here. There you go. Okay, then we've got 2 for decreasing. So what's my first one? Negative infinity to -3. So I'm not doing -3 to -3 because that's the gap. So I did negative infinity to -3 because that's the first one. And then what's the second one? -3 to 0. Okay. Max, is there a mountaintop in the picture? No. Is there a valley in the picture? Yes, it's a very sharp valley. What do I write for that? 0, -4. Good. I got the points. Okay. X-intercepts, I see 2 of them.
But you also see Y.
And I also see a y-intercept. So what are my x-intercepts? Okay.
Do you have to put U's here?
You do not. Because this is interval notation. And so I'm saying this interval and this interval. So it's from this x value to this x value, this x value to this x value. This is just saying one x and y, another x and y. So 2 different types of notation, even though they look so similar. All right. What is the y-intercept? 0, -4. Okay. Is the graph continuous? No, not even close. I gotta pick up my finger twice. All right, as I look at the left arrow, as I look at the right arrow. Okay, the left arrow is going up. It's going up. So I've got y, positive infinity. The right arrow is also going up. So left arrow up, right arrow up. Okay. Do you see why we started off with the units we started off with this stuff? Because it can get real messy. And I picked specific piecewise functions that were not terrible. So this right here is the not terrible version. That means these can get real messy. Okay, so let's go ahead and start working on this. Sound good? Okay. Ms. Rice, what is our homework? This. There's only 5 problems total. You got 4. Only 5. You got 4. You got a 3-day weekend. Okay.